Okay, so here we have the third question from the International M2 paper of June 2015. It's a framework question. The diagram that you see actually wasn't given in the question, but it's fairly easy to come up with that. It has told us it's uniform, so that's key, and it's told us the mass is 12m. It's also told us that there's a separate masses at the points B and C. Okay, now let's put these values into a table for x and y. Because it's uniform, we know that the centre of mass of AB is in the middle of there. So that means that that's got a mass of 3m, and it is going to have an x coordinate of 0 and a y of 3 over 2a. Okay, now this one here, the BC one, is going to have a mass of 4m. It's going to have an x coordinate of 2a and a y coordinate of 0. And then the rod AC is going to have a centre, it's going to have mass 5m and a centre of mass of 2a and 3 over 2a. Now in addition to this, you've got the two separate particles placed at A and B, B and C. So the 3m one is going to have, is located at 4a0, and the final one here is of mass 2m, and that's at 0, 0. The total of all of these masses here add up to 17m, and then we are trying to figure out what the the centre of mass is, x bar and y bar. Now there's a fairly intuitive formula for this. Sigma xi mi is equal to x bar sigma mi, and a similar one for the y coordinate as well. It's fairly intuitive. All it means is this times this, plus this times this, plus this times this, plus this times this, plus this times this is equal to this times this. And likewise, the same will be the case for the y bar. So let's just work with that. We've got 3m0 plus 4m times 2a plus 5m times 2a plus 3m times 4a plus 2m times 0 equals to 17m x bar. We can see obviously that the m's cancel. Okay, working that all out, we end up with, when we multiply all these out, we end up with 17x bar is equal to 30a. So that obviously means that our x bar is equal to 30a over 17. Okay, and we can do the same for the y bar as well. We can say that for y bar, 3m times 3 over 2a plus 4m times 0 plus 5m times 3 over 2a plus 3m times 0 plus 2m times 0 equals to 17m x bar. Again, the m's will cancel. Okay, and that finally, when we work that out, we get 9, well, let's just not rush it too much, we get 9 over 2a, because these are the only things that actually, plus 15 over 2a is equal to 17x bar. Y bar, of course, we're working out the y now. So then we find that y bar is equal to 9a, these two added together come to 24 over a, so it's 12a, and divided by 17. Okay, so that's, now we've got the centre of mass, we can think about the where the angles of the things. Now, I'm going to use a diagram that we've had above. Okay, so let's just see if I can use the draw menu. Okay, let's just draw it on then. I can't find the draw button, doesn't matter. Okay, so we know the location of that. That's basically located at, let's try and fit it in there. That's located at 30a over 17 and 12a over 17. That's the location of it. And now we need to find the angle, and it wants the angle, it's suspended from A, and the angle AB makes with the vertical. So that's basically the angle alpha there. So, let's change colour here. Okay, so we can see we've got a triangle here. A little bit small, I might recommend having such a tiny diagram when you're actually working this out. But anyway, this distance is pretty clear. That is just our x-coordinate, which is 30a over 17. But this distance here, I mean, by that I mean this distance, so that we can have, I'll redraw the triangle slightly bigger here. This is our angle alpha. That's the vertical here. This distance here is 30a over 17, as I've just said. And this distance here is equal to, because the length from here to here on the diagram is 3a. That's 3a minus 12 over 17a. And that makes it 39 over 17a. So, let's go back to red. Okay, so we now have the diagram, we have the things on our triangle that we need. We can say that tangent alpha, opposite over adjacent, is equal to 30a over 17, all divided by 39a over 17. Obviously the 17 cancels, the a cancels, so we get tan alpha is equal to 30 over 39. Okay, which is equal to 10 over 13. And we can work out the inverse tan of that. Which is equal to alpha, if we give three significant figures, which should be our default position here, especially when G is not involved, 37.6 degrees, which is the answer to the problem. So there we go. Find the centre of mass, remember it's a framework, and then just do a nice, careful diagram, and we're all done.